Alright class, in this lesson we're going to talk about transformations, and we're going to do a couple types here, and we'll do the last one on another video. So the first one we're going to look at is reflection, and there's two of those. So minus f of x reflects the graph of f of x about the x-axis. So it flips it horizontally, vertically. Okay? That's not that should be a bullet point. Maybe I should make that really clear so you don't think that's a negative sign. F of negative x reflects the graph of f of x about the y-axis. So that's going to be your horizontal flip. Okay? Dilations. A f of x stretches the graph of f of x vertically by a factor of a. So 2f of x makes it twice as big. Okay? F of ax compresses the graph of f of x horizontally. So I should underline compresses and horizontally there by a factor of 1 over a. This is the one that gets everybody confused, and the easiest way I can sort of make a description here that might make sense. Let's suppose me and one of the students here are running a cross-country race. So what the student doesn't know is I'm the fastest human on the planet. So when I run the race, I'm actually twice as fast as this other kid. So think about it. I'm still running up the same hills and down the same valleys and all that kind of stuff as the other kid. So I'm still going just as high and low as the other kid is going, but I'm doing it twice as fast. So it takes me half as long. So that's the best way I can sort of explain the way that the compression works. All right, so let's just do a couple quick examples. So I've got a graph here, f of x, and we're just going to do an example of each one of these. So first off, we'll sketch a graph of minus f of x. Okay, so that's this thing, and we just take it and we flip it. Okay? So notice the domain and the range, well, the range might change. In this case it won't, but in general the range could change because you're flipping y values, but the domain shouldn't. Okay? So it's going to look something like that. That would be negative f of x. Okay, and you can compare, see how they flipped? Okay, and then here, let me do that underneath. If we want f of minus x, that's going to be a flip, but it's going to be a flip on the y-axis, not the x-axis. Okay, so once again, so what's the deal here? The domain can change, but the range won't. Okay? So if we're flipping across here on the y-axis, it's going to look something like that. Okay, and you can sort of see between those two, see how this one's flipped this way. I like to draw a little flip sign like that when I'm trying to just say it. And for this one, I would say a flip sign like that. So vertical versus horizontal. And then 2f of x, what would that look like? Okay, so that means I'm changing the range. So I'm changing the y values. So I should go up twice as high and down twice as far. But notice when I do that, the domain doesn't change any at all. It's just the range. So that's something that affects the range and not domain, because it's a vertical change. Okay? So that's 2f of x. And then you can kind of sort of compare it to this one. Okay? Sometimes you can make it look the same, just to have it a different scale. Okay? Alright, and then we'll do f of 2x last. Okay, so this is supposed to be a deal where I'm going twice as fast. So this is going to affect the domain. Now, my domain is minus 2 to 2. So if I go twice as fast, I only need half of that. So the domain of f of 2x is going to be from minus 1 to 1. Okay? It doesn't do anything vertically, so don't make it go up higher or anything like that. We're going to run, like I say, the same course, just twice as fast. So it's going to look something like, and let me make sure I put a 1 there so you can sort of get the idea of scale. So it's going to look something like that. Okay? Like I say, this last one, This is the one that drives people nuts. This is the one they have the most trouble with. Okay? And all I can say is when you're looking on the inside, it's hard to see it with reflections, but with dilations and translations that we'll see next, it's kind of the opposite of what it says. So if it says f of 2x, it's really 1/2, that you're doing things by 1/2.